Hi everyone, welcome back to the channel, or welcome to the channel if you're new here. I'm your host Dalmas, and the aim of this channel is to make you a better data professional. So whether you're a data engineer or a data scientist, I'm here to make you much better than when you joined the community. So today we are going to look into mathematics, and in this video series I'm going to be touching some mathematical concepts that make data engineering much easier and data science much easier. And we are going to begin with differential equations, and I'm going to focus mostly on ordinary differential equations. So by the end of this video, you should be able to define what an equation is. So by the end of this video, let me just write it somewhere here. We are going to study ordinary differential equations. And before we enter into the ordinary differential equations, in short form we call them ODEs, I want us to first have an introduction of what an equation is. So this video is mostly going to be introductory. So what should you expect? You should expect to define what an equation is by the end of this video. You should be able to also say what a differential equation is. You should be able to say what an ordinary differential equation is. Then you should be able to tell the differences between ordinary differential equations and partial differential equations. So some bit of difference between ODE, that is ordinary differential equations, and PDE, those are partial differential equations. Then some bit of differential equations concepts like degree of a differential equation. DE is differential equation, so every time you see me writing DE, just know that I'm meaning differential equation. So degree of differential equation and order of differential equation. Then we can also look at some applications of differential equations. So some applications, real world applications, how you can use this knowledge in your day-to-day activities as a data professional. So let us begin with what is an equation. So I'm going to have here equation, because we're talking about ordinary differential equations. So let's get to remind ourselves of what is an equation. Obviously, I know you know what an equation is, because you cannot be looking at differential equations before you know what an equation is. But let's remind ourselves what an equation is. So you have an expression, a mathematical expression. It could be 5x. This is an expression. It could be 3y. These are two different expressions. And let's say these expressions represent a unit or a quantity of something, let's say kilograms. If you have these two weights, now let's assume this is a weight and this is a weight, and this is a both 3y and 5x are expressions that represent weight of substances. So let's say you have a beam balance with a fulcrum somewhere here. So this is the middle point, fulcrum, and on one side you have this weight 5x kilogram, and on the other side you have the 3y kilogram. So if these two weights are balancing, it will mean that you can express these two expressions, you can combine these two expressions using an equal sign. So you'll say 5x equals to 3y. And the result of what you've gotten here is an equation. So this is an equation. So formally, an equation is a statement that the values of two mathematical expressions are equal. So you have these two mathematical expressions are equal, and this is the statement. And if you look into Wikipedia, you'll find out that a mathematical formula that expresses the equality of two expressions by connecting them with an equal sign. So that is how Wikipedia defines an equation. So another example, so we can look at some examples of equations here. So we can have, for example, equation of a line, y equals to mx plus c, where m is the gradient and c is the intercept, and this is also an equation. You have equation for a right-angled triangle, the sides, so a square plus b square equals to c square. So now we know what an equation is. Let's go and try to find out what a differential equation is. Oh, I forgot to tell you at the beginning of this session that you need to know integral calculus and differential calculus for you to be comfortable with this video series or this lecture series. So we shall have some bit of brush up on differentiation and integration, but it will be good if you have seen it before. So if you haven't seen it before, I would suggest that you look for content somewhere to learn about differentiation and integration. So what is a differential equation? From the definition, a differential equation is an equation that contains one or more functions with its derivatives. Or it is an equation that contains one or more terms and the derivatives of one or more variables with respect to those variables. So let's say you have a function of x equals to dy dx. If you have seen differentiation before, you understand that this is differentiating y with respect to x. So the whole of this function that you see in the box the whole of this equation that you see in the box is the differential equation. So an example would be dy dx. This autocorrect is writing wrong things. Dy dx being equal to, let's say, 5x plus 3. This is our first example, and this is a differential equation, so this is a dE, because the whole of this equation here contains a derivative of one of the variables, and the derivative here of one of the variables here is here. This is the derivative. So other examples, I can get a second example to show you. So we have dy, let's say dy dx, yeah, being equal to 2 over xy plus 4x. So this is also a differential equation. We can look at a third one, say dy dt being equal to 3t plus 2. This is also, so all these are differential equations. So you can just say here, everything you see here are differential equations. So what is an ordinary differential equation? The difference, by the way, between differential ordinary differential equations and partial differential equation is the number of independent variable. Is it the number of independent variable. So let's look at first the difference before you get to know what an ordinary. Obviously, from the difference you will know what ordinary differential equation is. So the key difference between, let me just write here, difference between ODE and PDE. So the key difference between ODE and PDEs lies in the number of independent variables. So I'm going to show you some examples and hopefully it will make sense. So you have dy dx being equal to 2x plus 5. This is our first example, and this one here is an ordinary differential equation. And the reason why I'm saying it's an ordinary differential equation is because it has only one independent variable. So you have x being the independent variable, independent variable, and then y is the dependent variable. So you have this being ODE. So this is one example. Let's look at another example. I'm going to have a second partial differential du dx square plus partial of that partial of y square being equal to 0. So this is PDE, and it is a partial differential equation because it has two independent variables. So we can, let me just use this different color. We can have this is an independent variable, the x, and also the u is an independent variable. What have we done? Yeah, and then that this u here is, these are now the independent variable, and then the y is the dependent variable. So you can see if you have more than one independent variable and the equation is differentiating around them, then you're going to be using partial differential equations, the procedures and the processes and the methods of solving the partial differential equations. Mostly for this video series, I'm going to focus on ordinary differential equations, but in the future, I'm going to make video series for partial differential equations. It depends on how you respond, if this is more necessary for you to continue learning, and if you tell me that you want to learn also partial differential equations, then I will have to do it. So we know what a differential equation is. We know what ordinary and partial differential equation is. Let's look at the degree of a differential equation. So degree. The degree of a differential equation is the power of the highest order derivative. Remember, here we have this term here is a derivative, and also this term here is the derivative. So we are looking at the power of the highest order derivative. Also, I can show you examples, but before we move into examples, I want to show you some notations. You will see me writing dy dx like this. That is differentiating y with respect to x. Also, this can be written as y with this mark on top. Then you can also see me writing d2y dx square. I can also write it like this with two of those marks. I don't know the names. So let's look at examples for degree of differential equations. So we have 1. We can have dy dx plus 1 being equal to 0. So the degree here is 1, and that is because the power of this term, this is the highest derivative, the power here is 1. Let's look at another example. So I can have, this is the derivative of y 3 times, the third derivative, plus 3y with the second derivative, plus 6y first derivative, minus 12 being equal to 0. So the degree here is 3 because of this power. We can look at another example. Hopefully you are getting the gist. Let's look at dt dx plus sine of dt dx equals to 0. I would like you to guess what the degree here is. And yeah, you're wrong. So this has undefined degree because part of the definition of degree of differential equation says that the equation should be represented in the form of a polynomial. So this is in the form of polynomial. You can see there is this, you can form a polynomial, and this one does not form a polynomial. So the definition itself says that the degree of a differential equation is the power of the highest order derivative, where the original equation is represented in the form of a polynomial equation. So whenever you see this sign, you have undefined degree. Did I talk about the order? I don't know if I talked about the order of differential equation. I think I talked about it. I'm not sure. Anyway, oh, we have, yeah, somewhere here. So let's look at the order of differential equation. Order. So the order of differential equation is the order of the highest order derivative. I think we talked about that, did we? No, we didn't. Just looking at it. No, we didn't. Yeah, confusing this lecture with another. Okay, so the order of differential equation is the order of the highest order derivative present in the equation. So we know the derivatives. So let's look at an example. One, we have dy dx equal to 3x plus 2. This one here is order 1 because we have only differentiated y with respect to x only once. So this is of order 1. Let's look at another example. You have d2y dx square plus 2 dy dx plus y being equal to 0. So this order here will be order 2 because we have differentiated y with respect to x twice. So this is order 2. The third example will be that plus that equal to kt, and that will be order 1. Yeah, so this is the order of differential equation, and I'm going to read for you the definition again. So the order of the differential equation is the order of the highest order derivative present. It's kind of confusing. We're using order every time in the definition. Very weird, but that is math. Anyway, so let's recap a bit. A differential equation, the ordinary differential equation, because we are focusing on ordinary differential equations. Ordinary differential equations. So from above we can say that ordinary differential equation is a differential equation dependent on only a single independent variable. That's it. And we can look at an example, a real world example that you could be used to. Let's say Newton's formula for force. So we know that force is equal to mass times acceleration. And let's say x t is distance covered by object over the time period. So x is a distance, function of distance. That's why I put x into brackets t. So x being the distance covered by an object over a period of time, then the velocity, this is distance, then velocity will be change of distance over change of time. So that would be dx with respect to t, but this is also a function of time. And with that spirit, we can say acceleration will be d2x dt square, but that is also a function of time. And we know that since force equals to mass times acceleration, we can say, we know that force is a function of time, distance, and velocity. So we can say force being a function of time, distance is a function of time, that's why I'm writing like that, and velocity is also a function of time. Then this will be equal to mass times, mass is a constant, never changes, times the acceleration that we've seen above, that is d2x dt square, which is the function of time. Yeah, so this one here is a differential equation, and when you try to solve it, you'll be solving a differential equation. So the real world applications, let me just write them down so that you get well motivated to follow this video series, and hopefully this will help someone out there who will need to do differential equations in their job, and not just importing TensorFlow or importing some math library, but do some good work and good research related to data. So some real world applications to motivate you. Real world application. Also, if you are a university student and you're watching this, just know that me talking to professionals is a good enough motivation that this is going to lead into somewhere in your career where you're going to build a career on. Yeah, so differential equations, I'm talking to data scientists. That means that you can be a data scientist or a data engineer if you are a student. Also, if you're in Busitema University, hello. Anyway, I've digressed a lot. Let me look at examples. So if you want to study growth and spread of diseases in the human body, so let's say study spread of diseases, differential equations will be very important. For those working with electricity, if you want to predict the movement of electricity, you can use differential equations as a tool. Or if you are in finance and you want to calculate optimal investment strategies, so optimal investment strategies, then differential equations can be very, in fact, they're going to be very, very useful. For you to join finance, you have to have knowledge of differential equations, ODE being primary knowledge for you to have, but you need to have the knowledge, because if you want to predict returns and how you can invest and diversify your portfolio or portfolio of your client, then you need to know differential equations. Yeah, so I hope you've liked this. This is what I wanted to share with you. I'm going to leave you with some questions that you can solve if you want, or don't solve if you also don't want. But these questions is just for a simple practice to see if your time has been worth it watching this video and trying to learn an introduction to differential equations. So I would like you to just state somewhere in the comments or somewhere else, or you can just set it for yourself. The first question will be, what is the order of these differential equations? So tell me there, what is the order? So I have here 1 being that equals to 2y plus 3. The second one being y that minus y that plus y equals to 3x. The third one being y that plus 2x minus y being equal to 0. So yeah, just state what the orders of these differential equations are. The next one would be, what are the degrees of these differential equations? What is the degree? So 1, I have y square minus 3x plus y equals to 0. The second one being y that plus y minus 4x being equal to x squared. And then the third one being equal to y that plus y equals to 3. So yeah, these are the exercises that you can take on less than 5 minutes, and you gauge your knowledge of differential equations. I'm going to leave the answers of this in the description, but before you look into it, have your answer somewhere and tell me how correct you are in the comments. Also, if you haven't subscribed now, just subscribe in case I upload the next video. The next video is going to be first order differential equations. You'll be notified. Until then, I hope I have made a difference in your life. Thank you so much, and bye.